The ambiguous case in trigonometry is the case where you're given an angle, a side adjacent to the angle, and a side across from the angle. Now there are a couple of different things that can happen in this situation, one of which is that the side they give you across from the angle isn't long enough to reach. This really isn't fair, but if they do this to you and you try to solve for angle C down here, it just isn't going to work. You'll get a sign value which is greater than 1, and you just can't solve for it. The second thing that can happen is this side across from the angle is longer than the side adjacent to the angle. And in this case there's only one possible triangle that can result. Now I always draw this with the right, or with the angle down here on the left hand side, the adjacent side sticking up in the air, so I can think of this side over here being on a hinge. So for example, if it's long enough to reach and it's shorter than this side, it could reach at C in this position, or you could swing it over to here and this would be your triangle. And this is what's referred to as the ambiguous case, because you don't know which triangle is going to result from the information that you're given. Actually, there are two possible answers. Now, I've taken an example here where I've got a side across from the angle. It's long enough to reach, so I set up the sine law. Sine C over 10 equals sine 40 over 7.5. Very straightforward. You can solve for angle C. Once you've got angle C, you can subtract angle C and angle B from 180, and that'll give you angle A. And then we can go forward and solve for little a. It's a straightforward use of the sine law. You can, if you're not sure how to use the sine law, you can look at my video on that particular law. But if you draw what we call an acute triangle here, it's a very straightforward setup. Now what you have to realize though, that this side coming down here could have come back this way. Now, because we solved the first triangle and got an angle of 59 degrees, because this is an isosceles set up over here, this is also 59. So if you subtract the 59 from 180, you've got 121, and you've got the angle inside this obtuse triangle. This is 19 degrees up here, and again, if you take a look at the situation, it's a straightforward idea from there on. The only side missing is little a. Little a over sine 19 equals 7.5 over sine 40. And you can solve for side little a. So the two possibilities are the acute angle, which most students would draw if they weren't even thinking about the ambiguous case. But you have to realize that this side, if it's shorter than 10, can swing over to here and create a second possible triangle. One last thing I should mention, if you want to know whether or not you're going to encounter the ambiguous case in a question, you might want to solve for the height, which I've marked here with a dotted line, h. That creates a little right angle triangle here. The sine of 40 equals opposite over hypotenuse, h over 10. Solving for h, we get 6.4. So that means if little a, the side across from capital A, is less than 10 and greater than the height here, which is 6.4, you will have the ambiguous case.